and welcome to our webcast. My name is Caroline Lim, and I'm the Marketing Programs Manager here at InfoChimps. I'm excited about our webcast today. Measure twice, build once, real-time predictive analytics with Think Big analytics. But before we jump into that, a little housekeeping. First, we are recording this webcast. We'll send a link to the video via email early next week, so please look out for that. Second, ask questions. We want your participation in this webcast. Feel free to use the chat functionality in your GoToWebinar control panel. We will be monitoring this channel, so we will answer your questions during the webcast. We will also be having a Q&A towards the end of the webcast. And lastly, we have a Twitter hashtag. It's hashtag RTAnalytics, and you'll see that at the bottom of the slide deck. So we hope to see you all talking about us there. Without further ado, let me introduce you to InfoChimps CSO and co-founder Drew Vansel.
Thanks, Caroline. Hi, everybody. This is Drew Vansel. Thank you so much for joining our webinar today. I work with InfoChimps. We are a next-generation big data stack to power all sorts of interesting applications for our customers. I'd like to introduce you to my co-presenter, Douglas Moore at Think Big. Douglas?
Thanks, Drew. Thanks, everyone, for your time today. I'm Douglas Moore with Think Big Analytics. I'm principal consultant and data architect.
During today's webinar, we're going to be focusing on kind of one central theme, which is that big data can be expensive technology with which to make mistakes. And so it's like all good carpenters, it's important for us to measure twice and then build once. And there's an iterative process that both our companies, InfoChimps and Think Big, like to engage in. Understand the problem, model the solution, test it locally, and then grow the infrastructure to support the actual solution in production. We're going to focus on this theme on both sides. We're going to start with Douglas going through an interesting use case that Think Big Analytics has solved in the ad tech space. Then we're going to transition, and I'm going to talk a little bit about InfoChimps' own cloud technology and how we can support the kinds of solutions that Douglas and team at Think Big can create. Finally, we're going to talk a little bit about the advantages of working with a technology provider and service provider like Think Big and InfoChimps together. And with that, Douglas, I'd like to turn it over to you.
Great.
Oh,
Thanks.
excuse me. Actually, I'm mistaken. I've forgotten the order that we did this in. Excuse me, everybody. We're going to start with a poll. We want to make sure that our polling software in the webinar is working. We want to make sure that everybody can participate. And so let's go ahead and start with our first poll question.
Thank you, Drew. So our first poll will be, how advanced is your organization's approach to big data? I'll go ahead and launch that poll now and give everyone a few minutes to bring in their responses. Okay, we're about 84% voted. If you haven't voted already, please put in your response now, and we'll go over the results here in just a second. All right, I'm going to go ahead and close the poll. Here you go, Drew.
Okay, that's about, I think, as we expected, that there's a lot of folks out there who are starting their journey into big data. And there's actually a few folks out there that have implemented something. And we'd love to, feel free to chat and send questions in. We'd love to talk about specifics for both those that haven't started and those that have. And now I think after this first poll, Douglas, let's launch into a Think Big use case.
Well, actually, Drew, let me first describe a bit more about Think Big Analytics, what we're doing. We're a pure play big data professional services firm. we have three major service offerings. Our Imagine is where we help company executives build a big data strategy and roadmap. How will big data fit within your enterprise and integrate with your existing ecosystem? Our Illuminate services are hands-on technology training and education. One differentiator here is that our training is given by principal consultants such as myself, who've been in the trenches and delivered many solutions. And then finally, our bread and butter is the hands-on data science and data engineering. And this is where we help bring your solutions to life. So, so the use case here. So imagine we engaged with a ad tech network, an up-and-coming ad tech network, and they were trying to solve the biggest problem that local advertisers had with their local online newspapers. So imagine you're an owner of a local Mexican restaurant, and you want to gear up for Cinco de Mayo, which is topical, and you want to buy some ads in the local online newspaper. Now next to some content about festivities running in the nearby park. So now you've bought your ads, you go to the local newspaper and you click refresh and you look for your ad. You don't see it. You hit refresh again, no ad. You hit refresh again, no ad. With the current display ad technology, there's no guarantee that your ad will be shown where, as a local restaurateur, you want to see your ad next to, and that's an article about Cinco de Mayo. So AdGlue, our customer, they engaged us to help with their three use cases with their big data platform. So they needed to scale their batch analysis pipeline. The time it was taken to run was increasing every week. They needed to generate lively stats for their advertisers to help them, help convince that it was working, and that, when their friends and neighbors and community members clicked on the site, that it was registering the activity. They also needed to provide recommendations to the advertisers. And this is where we brought in some data science to the mix. And they also needed a much better prediction algorithm. They needed to predict the number of page views over the next 30 days because of the business model. So the environment was Amazon Web Services. They already had version 1 in production, a local newspaper. So the project plan was roughly 8 to 9 weeks. It was combined data engineering, data science engagement. The staff was myself, the architect, project manager, one of our data engineers, and 2 of our data scientists. We also worked side by side with our client engineers. And we do this often and with purpose. We want to have a knowledge transfer, big data techniques and engineering. We want to be able to transition it to our clients and let them be able to run and grow and expand and maintain that platform if they so desire. So I'm going to talk a little bit about the predictive analytics process. So our data scientists would engage with the client, and they would begin with listening to the client. What are their hunches? What do they think are predictive? What do they think is not predictive? What do they have questions about? And learning about their vertical. And then we would begin digging through their data, their raw log files, try, figure out what's predictive, what's not, just get an understanding of what's there. Then we would create a cogent research agenda. This would be a set of hypotheses that we would go through and try. And then we would begin, a methodical process of testing each of these hypotheses and learning, if that approach would be useful and productive. So then comes the process of creating a production quality predictive model. Well, 80% of work is in data cleansing, aggregation, conditioning the data to train your model. And we have to develop a process and code, using tools like Pig and R and Hive to train this mathematical model, this predictive mathematical model. And these training parameters that we create then are used during the predictive model execution process. So we have to work close together, with data science and data engineering to make sure that we can successfully pull both of these off and that we can create a production-worthy platform. So some of the analytics challenges, what functional forms will predict future impression counts, up to time t? What robust estimators are there or can we create? Medians, would they work better than means, to cope with the outliers that are in the data? This being an ad network, when it's plugged into a new property, how do we distinguish between new articles and old articles, that we're just seeing for the first time? And then how well do these impression counts actually correspond to real humans? These are some of the real world challenges that we'd have to deal with in analytics and engineering. So now, why real time? A lot of companies are doing this with batch analytics, running this daily and updating. Well, one aspect of it is much better end user experience. Now back to that restaurant owner. She's like sending out to all her Facebook friends and LinkedIn and Twitter, say, hey, look at her new ad next to this article, and while she's doing that, while she's talking on the phone with her friends, she wants to see those counters move. It helps her feel that this whole thing is working and reliable. Next. So additionally, real time is very important, especially with content. A study done by Hilary Mason of Bitly showed that content half-life is measured at 3 hours. And it's very important to catch these fast-moving events and then offer to advertisers, hey, catch this rising wave of interest in this particular article and capture a lot of impressions against that. So, and this is, with real time, this gave us additional skills. These features were then possible. Back to that trend analysis I was just talking about, recommend hot articles. What if that festival was mentioned on Oprah? The views would explode. You want to be able to sell content against that or advertising against that. So let me talk about a little bit about the architecture that we were looking to build. So we had in place ad serving network and a management network. So we wanted to collect those events coming off the edge server as soon as they were created. So we were putting that into a queue. We want to put that in a queue, and we want to use Storm, to manage the queue, to filter out bots, do bits pieces of the real version of our predictive modeling and data collection. We wanted real-time performance counters as well. So with Storm, we needed memcache to track some state, because of the distributed nature of Storm. We needed to track the, tuples that might fail, make sure they don't repeat forever. So at Storm was we'd store the log data impressions and the clicks to a distributed file system. And then we also want to capture aggregates in a NoSQL database so we could access them later. And then over here on Hadoop, we would do batch processing, the archive logs. We train the models on a massive historical data set. And we use Hadoop streaming in R and to build model parameters. So between the real-time performance counters, the historical performance counters, and the model parameters, we have in this gate prediction box, we would again use R. R is kind of like the Swiss Army knife for data scientists. We would combine these data sets, from the speed layer and from the batch layer to produce a prediction of how many impressions are going to occur on this content over the next 30 days. And then that would be then served up to the ad buyer. So this is basically the blueprint that we're looking to build to. Next slide, please. So next step deep into analytics architecture, we have the real-time layer across the top, and you can see how we have a simplified topology shown in this slide of what I just spoke about. So this time series bucket bolt was very important to capture that and update the recent history of what's going on. And so Hadoop then would look at the long history, 30 days, 6 months, 12 months of data, and create time buckets there. And so from this buckets, we would create a predictive model. We would train our predictive model, and we'd make those model parameters away. And then again, in the web server, based on a request, we combine these 3 data streams with the help of R to produce that prediction. So just kind of hit that once more. So next slide, please. So the whole solution approach is quite similar to what Nathan Mars, formerly of Twitter, is talking about, in that you have your batch processing, and you have your speed layer, and then you put the 2 together, and we get a real-time prediction. So on the massive historical data set, well, we were keeping that in S3, and we're analyzing this with Hadoop, Pig, and R. Now, to deal with the most recent past, well, we would collect that with Storm and the aggregates we'd keep in NoSQL, and we'd analyze that with R and web service. So this is a basic solution approach. Next, please. Looks like time for a poll. What do we have?
Thank you, Douglas. So our second poll is, which element of the big data stack is most important to you? I'll go ahead and launch the poll and give everyone a few moments to respond.
There's a comment coming in about the question, which NoSQL databases are we using? Here, for the purpose of the poll, let's just use our imagination. Any database that you've heard of. We're really just asking, is the ability to store data in a database so you can access it very quickly, is that really important to you?
Okay, we're about 77% voted. If you haven't put in your vote yet, please go ahead and respond, and we'll go over the results here at any moment. Okay, I'm going to go ahead and close the poll, and here are the results.
So this is a marvelously well-split set of responses. There's quite a few folks voting right now, so it's very unlikely to see such a close split, I think, unless really folks are acknowledging that each of these different components really have a lot of value in the stack. And I think that's something that InfoChimps definitely agrees with. You'll see that in my slides coming up. And I think this also reflects the story that we just heard from Douglas at Think Big. All 3 of these components were highly important in constructing the real-time and historical ad tech recommendation engine that the team built. So really great to hear that. That's actually a great segue for me to talk about InfoChimps and kind of our product mix. We really recognize that these three categories of technology, namely the ability to work in real time, the ability to work in batch, and the ability to store data in databases for ad hoc queries or analysis, all three are crucial to really building and supporting big data applications. Hadoop alone can do some reporting, and real time is great for just processing data, but in order to really build an application that has data ingestion, analysis, complex reporting, it's important to combine these technologies. So InfoChimps is all about kind of any analytics. We also take these services, and our product puts them together into a single deliverable, a single box, if you will. We put nicer interfaces on it so we can handle structured data, unstructured data, small data, big data, real-time, batch data. So we really approach any data using any kind of these analytics as well. And then finally, to really provide flexibility, we take our entire cloud services, the real-time, the batch, the ad hoc components, and we deploy them in a number of cloud environments. Cloud is really important for us as a big data company. We love the ability to quickly expand infrastructure as we learn more about a problem. Going back to the central theme of this webinar, the we learn more model, the more you understand about how your infrastructure is going to have to change and grow over time. Sometimes you may move some piece of code or some algorithm from a real-time context to a batch context. That may change your compute requirements. So we really like to have an underlying cloud supporting our product. And three clouds or three cloud models that we support are the public, the virtual private, and the private. The public cloud is we consider our fastest to get started. This is Amazon Web Services or similar public cloud. We can build our cloud solution there in literally a few weeks. The virtual private cloud is our model where we take our full service and we deploy it in a private data center that we have a relationship with. This is the Tier 4 data center. It's lights out. It has some of the best statistics on uptime and availability in the entire industry. And so it's a great environment to take for a larger scale project, or a project that has incredible uptime or availability requirements, or a project that has some intense requirements around privacy or data access and security. Finally, we can take our entire solution, we can deploy it in what we call our private cloud model. This is really saying if you at a customer site have a data center that's already meets the minimum requirements that we need for our product, then we can deploy into your data center as well. So there's a lot of flexibility. The three components that we all as a webinar audience here just pretty much split 30-30-30 down the line and agree that they're all three important. All those components deployed where you need them in whatever cloud environment is the most appropriate. And there's a lot of questions coming in about the underlying architecture, guys. That's great. Keep just asking through the chat, and we'll make sure to address them at the end of the conversation. I'll focus just a little bit on how some of these components are connected within the InfoChimps cloud. This diagram should remind you at a high level of the diagram that Douglas showed you earlier, really ingesting data on the left-hand side, moving it into a solution that has a real-time component that's queuing the data up and processing it. That's our Cloud Streams component, as I spoke to. Moving the data into Hadoop for that batch analytics, that 30-day time frame that Douglas spoke to, collecting recommendation and tuning model parameters over, and then also storing data either from Hadoop or live from Cloud Streams directly into some databases in our queries layer. And that really supports a lot of access from the right-hand side, right? Folks coming in with API-driven applications that are querying the databases or affecting the way the data is processed in the stream. Folks coming in with analytics programs like Pig and Hive and other traditional Hadoop ecosystem tools to look at the long-scale analysis, stuff like R that the Think Big team brings to bear. We also have our own access layer. We call this Wukong. It has the great ability, which is kind of unique in the big data landscape, of being able to write an algorithm, test it out locally, run it in Hadoop, and then run it in Cloud Streams just as equivalent. So within Hadoop as well as within Storm. That's a unique differentiator for our product, and it's a really big accelerator. In terms of, again, going back to the theme of our webinar, it allows you to write an algorithm, test it out locally, and then push it into whatever part of the solution you decide at that moment is the best implementation of this algorithm. So it helps you to be iterative. It helps you to move very quickly through understanding your problem domain, modifying the solution, and growing the infrastructure to be able to support it. I want to focus just a little bit more on our real-time ingestion layer. This was so crucial to the problem that Douglas and team solved at AdGlue, the ability to ingest data in real time through a variety of input channels, the ability to queue it up just in case there's ever downage or out times or anything, the ability to process it right in the stream in memory at extremely high throughput within Storm. In the Think Big case, we're actually reaching out to existing data stores that have trained model parameters built into Hadoop, right? So bringing in some of the knowledge that we learned in that batch mode right in and leveraging that in real time as new data is coming in. And then finally, writing the data out to whatever destinations are appropriate. So that could be responding back to an API request, that could be writing into one of the NoSQL or SQL data stores. It could be sending the data out of the system to support some external application, whatever you need. So this is a pretty robust and scalable, especially to high volume and high throughput solution that combines two of the most leading edge technologies in the space. Storm in the middle from the good folks at Twitter to help us process large numbers of tuples very quickly, and Kafka on either side to act as an input and output queue. That comes from the good folks at LinkedIn. So we're really taking two of the web's most successful big scale data companies, taking two of their great open source projects and really combining them to sort of give every company that wants it the kind of scalability of LinkedIn and Twitter. I want to tie it all together and speak just for a minute or two about one of our customers and how we were able to help them massively accelerate and lower the cost of support to building a big data project. The customer we worked with is a company called Postmedia. They're Canada's largest media conglomerate, formerly Canada Post. They have a long-standing history of collecting what might be called traditional media data sources from traditional media. This is things like television transcriptions, radio transcriptions, print, and magazine data. And they had a great product that allowed you to track that content, email it out, distribute it, sort of really create engagement for your brand and your company. They want to move into new media. They wanted to add blogs. They wanted to add Facebook. They wanted to add Twitter data. This is a massive increase in scope and scale from what they had already running, and they knew they couldn't. They wouldn't be effective doing this on their own, as they would be working with a partner like InfoChimps. So what we're looking at here sort of represents a very broad view of the end state of the application that the folks at Postmedia built. It ingests data from these new and traditional media sources. That's handled with cloud streams. It processes that data, adding a lot of value and a lot of pretty sophisticated algorithms in the middle. This is exactly the kind of stuff that the team at Think Big does an excellent job providing to customers. The ability to do sentiment analysis, to write special purpose algorithms that leverage historical as well as real-time data to measure influence, but interestingly influence in the Canadian market, right? So some pretty cool and rare pieces of contextualization or values being added by this Postmedia solution. Finally, on the right-hand side, and this was a great experience for the media team. On the right-hand side, there's an application. That application isn't a big data application per se. It's a pretty standard PHP-driven web application. But because it's able to use the APIs within the InfoChimps platform to pull out data from some of our NoSQL databases, it's powered by big data. So the same resources internally that Postmedia already had that were building their original applications were able to seamlessly plug into this new world. And instead of having to solve the back-end problems of massive scalability, how are you going to process hundreds of millions of tweets and blog posts and articles per day? Instead of having to solve those problems themselves, they could work with InfoChimps to lay the technology, manage it, and deliver it much more quickly to market. So I'd like to close the introduction to InfoChimps with a quick poll again, really kind of exploring a little bit more about folks planning on building a solution. Caroline?
Okay, so this is our last poll for the webinar. Say you're building a big data project. Which time frame would you want to build a production solution? I'll go ahead and launch the poll and give everyone a few minutes. Thank you. Okay, we're about 66% voted. If you haven't voted already, please go ahead and place your vote, and we'll go over the results here shortly. Okay, I'm going to go ahead and close the poll. Here are the results.
Okay, wow, we have some, that's nice to see. There's a lot of ambitious folks out there. 30 days is sort of the minimum amount of time, I think, that we have found in certainly our experience in InfoChimps. I think there's a parallel of Think Big. Douglas, feel free to weigh in and comment. 30 days is the sort of minimum time frame over which we can really engage and start to show value. So the 9% that want to move faster than 30 days, better get started soon. 90 days is a much more reasonable time frame. That's a great sort of chunk of time to scope out a solution, get something built, especially if we're building quickly in a public cloud kind of environment, and move something into production. And then, of course, for really big projects, stuff that's going to be highly complicated, have big high availability or disaster recovery requirements, massive throughput. Some of those projects will take more than 6 months. And so, good on the folks for recognizing that that's the right timeline. I'd like to transition now into just, as we kind of close the webinar, having spoken quite a bit about Think Big and quite a bit about InfoChimps, really want to close making the case for big data is too hard right now for organizations to do it on their own. If it's not your specialty, if it's not core to what you do, it's a really big challenge to do it successfully. A survey that we commissioned last year of over 300 Fortune 1000 companies, commissioned, organized by us and folks at the SQL Server Worldwide User Group, we found that over 55% of enterprise big data projects have already failed. That's a remarkable statistic if you think about how much money, how many man hours, how many servers must have been bought in pursuit of those projects. Big data projects are big. They have large footprint on the organization. And so when you look at that failure rate, you look at how truly expensive it is to support a solution like the one that Douglas described, for AdGlue. It's got real-time components that have to be up all the time. It's got historical components. There's massive data storage requirements. It's truly complicated and very challenging for a company that, if it isn't their core competency, to do on their own. And we argue that if you're contemplating building it yourself, if you decided that building it yourself is not the right option, that you want to build with a vendor, we argue that InfoChimps and Think Big are the right pair. We're able to together move very, very quickly. The folks at Think Big have tremendous experience. They're some of the most original thinkers in this space, and they're published authors and experts. Really help, in their words, help you imagine and illuminate the potential around big data for your company. And of course, there's high quality and it's a proven service. We're both American onshore companies. We send our implementation teams out to visit directly, to work with stakeholders, to really scope out the solution so that we can deliver it correctly in the allotted time frame. We have a lot of existing and highly successful blue chip customers with massive data installations, processing over billions of events per day. And of course, back to the theme of the webinar, we aren't a waterfall kind of solution. Other companies focus on measuring, scoping, testing, and then finally deploying so that we can move in an agile way. That's not something that a lot of folks can promise in the big data landscape. So finally, we thank you for participating, and we've accumulated a lot of questions during the webinar, so thank you folks for being open. Please keep sending them in over the chat, and I'll turn it over to Caroline to kind of to take us through.
Thank you, Drew. So our first question comes from Guido. For you, Douglas, which NoSQL database are you using in your solution?
Well, there are many choices on the, for many of the serving up APIs and queries, Elasticsearch is very powerful. If you're looking, say, if you were spinning this up on your own, you know, for cross data center replication and others, we often look at Cassandra. And then for low latency analytics, we look towards HBase.
Thank you, Douglas, for your answer. I have another one for you from Steve. What types of predictive analytics algorithms did you evaluate, and which ones did you choose for production use?
Okay, thanks, Steve. That's a very good question. The I would need to get back to you on that. Our data scientists did a lot of that work in analyzing that, and that's also a little bit of the secret sauce that the client's holding close to the vest.
All right, thank you, Douglas. I'll give Steve your information after the webinar, so you can go ahead and talk to him directly. This next question is for Drew from Julia. What mathematical methods do you use in the black box? Is it a black box, or can the users adjust the model?
That's an interesting question, Julia. I think if you allow me the liberty of reinterpreting a little bit and thinking about the question behind the question, I'm sort of seeing, hey, how configurable is your service? Can I customize the way that code runs inside of it, or am I sort of stuck using what comes out of the box? I'll answer no. It's a highly flexible service. Our product is ultimately, it's not an application. It's a set of services that support applications. And your application, like the one that ThinkBig built for AdGlue, like some of the other ones that our customers in other industries have built, can have whatever custom logic, whatever mathematical algorithms that, whatever secret sauce, right, that you can put in it. That's completely up to you. Our technology really supports any kind of application use of the underlying frameworks like Hadoop, like Storm, so on.
Thank you, Drew. The next question comes from Gus. You talk a lot about real-time. Where does Impala fit in with the real-time world?
I guess I can answer that a little bit. I'd be curious for your interpretation too, Douglas. In my world, Impala is a wonderful new tool that feels like crazy future magic. It's capable of doing things that I haven't seen before from a lot of other technologies. At the same time, it's definitely new, and we haven't operationalized it at InfoChims at the massive scale that we've operationalized things like Hive or Storm or some of the other technologies that have been around for a little bit longer. But with that said, I know that we're very, very excited about Impala, and we are actively evaluating it for inclusion in the standard set of Hadoop ecosystem tools that we ourselves deploy at InfoChims.
Yeah, Drew, let me jump in on Impala. So, yeah, at ThinkBig, we see that serving, doing ad hoc queries across your entire massive data set, your historical data set, that you would keep on Hadoop, and getting results back in, say, seconds, not tens of seconds or minutes or hours, but getting results back to your ad hoc queries in seconds. Now, Impala is very good at doing these queries and producing some answers to answer those ad hoc questions and driving visualization tools such as Pentaho or Tableau. But Impala is not about transforming data and moving data around. That's where
a great point
comes in. And it's not about, processing streams with low latency either. So it's more about ad hoc, full data set analytics.
And I think that goes back to why we have multiple of these services together, because they all provide really a lot of value, but none of them can do the job of all of them, right?
Absolutely, and it's all about finding the right combination of technologies, excellent platform that they're deployed on, and building the analytics and application logic, and bringing it all together with appropriate project management.
Thank you for that, Douglas. I actually have another question for you from Urpana. What if I don't understand what I want to build? If I can't specify upfront what my business problem is, can you still help?
Well, this excellent question. This is where our Imagine comes in, and this is where we work with your ongoing business and help you identify um, problems, challenges, opportunities that you may have going on in your business, and how big data solutions across the spectrum may apply and may deliver value to your business. You know, whether it's an increased lift in marketing, quicker time to market, better customer service, you know, and being able to answer that phone more quickly and having the data available more quickly. So this is where our strategy and road mapping session will help flush out use cases for big data to help, uh, you know, help your business move forward with it. But thank you. That's an excellent question.
Thank you, Douglas. The next question is for Drew. Do you have any matrix like how many message per second the framework can process, as well as how much size of each message?
Okay, so that sounds like someone who understands and has played with these technologies before. You're asking some pretty key questions, and I can't say off the top of my head, yes, it will be this number, because I think the truth is that messages per second ingested or rate of data processing, these are figures that are highly variable, depending on the algorithm that's being applied, depending on the shape and size of the data source. It's hard to give it's difficult for me to give hard numbers and defend them. I can give you a very rough estimate. We tend to look at on the order of thousands of messages per second if each message is on the order of, let's say, half a K or half a kilobyte or a kilobyte in size. Good. And how many thousands of those half a kilobyte to kilobyte messages per second? It really depends on the situation, but certainly thousands per second seems like the right figure of merit for our streaming ingestion flow. Of course, Hadoop and similar tools will process many more than that messages per second because they're operating in kind of a batch mode, but that's a rough way to do it. Part of the value that we provide, honestly, and Think Big team does this very effectively as well, is when we start to scope out what your problem is, what your data looks like, you know, give us samples of it, and we'll run it through these systems and be able to actually estimate those numbers a lot more readily. That's what helps us do our own internal sizing when we deliver one of our own InfoChim solutions, is that we've already worked with the customer up front to understand how many events per second are coming in. Okay, great. How do we actually perform on this particular business problem? Okay, now we multiply those out to figure out what the actual infrastructure footprint needs to be.
Yeah, and our strategy and roadmap, along with our project definition, we get into what I call volumetric analysis, look at your requirements, and then make sure that we have the right technologies and that they're scaled appropriately, and help you figure out budget numbers. But thanks.
Thank you, Douglas. This is actually a follow-up question from Sanjeev to Drew. Storm uses 0MQ, and 0MQ having some limitation if the message size is very large. How does the framework handle this problem for very ingestion rate?
Okay, interesting. So my guess is that, you know, if you're sending in messages that are defeating the Storm, or excuse 0MQ's maximum message size, in some senses you could say that, hey, we can tune that variable and make it a little bit larger to accommodate you, and sometimes that's the right approach. But my guess is that if really we're hitting a limitation like that, then we're thinking about a message as too big of an object. You know, if a message is itself, you know, 400 megabytes in size, that seems an inappropriate size to use as an atomic object that's moving through the Storm framework. We would encourage splitting up that object into smaller pieces before it gets on the wire, and that would be sort of using Storm in the right or intended way. If that's not possible, then it's always, you know, a good decision to maybe use a different technology. Maybe say, hey, how do I really, if these are huge payloads, do they really have to be done in real time? Oftentimes, huge payloads kind of correlate with more of a batch ingestion process anyway. So maybe the right process becomes not doing that problem in Storm, but then bringing Hadoop to bear. And again, this goes back to why it's so important to have all these tools available at the same time when you're working with a real-world application.
Thank you, Drew. So we have a couple more minutes. We actually have like around 10 more minutes for more questions, and I invite everyone to ask as many questions as you would like, and we will try to answer them within the webinar. Our next question is from Tara, and this is for you, Drew. The underlying software changes all the time. We don't want to implement something and it become obsolete before implementation. How do you prevent this from happening?
The passage of time, yes. Well, one of the things I think this is someone sounds like this is a question for someone that had this experience of having built something on one database or one technology or one framework and realizing that 8 months later a better thing has come out. Now, we've had that experience here internally at InfoChimps enough times in this fast-changing big data landscape that we've kind of taken it as a ground truth. The technology will always change. And instead of trying to prevent that or trying to engineer around it, we accept that. And instead what we do is we create interfaces. And we encourage our customers to use our more abstracted interfaces, which we feel we can defend. And so when Flume gets replaced by Storm, when Hadoop gets replaced by whatever will replace it one day, we won't have our customers' code targeting those underlying systems like Hadoop, like Flume, like Storm. We'll have them using our own interface, which we can defend forever. And we're committed to every time we make a technology change underneath the hood to changing the way the interface couples to the new technology so that existing customer code is unaffected. And we've already done this one time. We've already had a shift from Flume to Storm in our real-time cloud streams product, and we've transitioned customers right through that change and without having to change any of their application code because they wrote it in our more high-level Wukong approach.
And yeah, and Drew, it's great that a platform like InfoChimps can deal with the underlying nuts and bolts of the technology. From a project point of view, we make sure really drive to that value that in very short time periods, something between 5 to 8 weeks, and then. Because your business can change over long implementation cycles, and you don't want that. So you'll want to structure your project to engage and get value as quick as possible. And this is something that we really stress with each and every client is to structure the project. We help them do this, and help select platforms like InfoChimps, which can deal with these with the rapidly changing landscape of Hadoop and big data.
Thank you, Douglas. I actually have another question for you, Douglas, and this is from Sam. Is Think Big noticing more projects are exploratory, early, insights-driven, or production apps, dashboards, IB tools? For which projects is predictive analytics most useful?
Good question. So it's kind of like the life cycle or your path, your big data path. So a few years ago, and not that many, maybe 2 years ago, people were asking, what's Hadoop? How's it useful? All that stuff. And then a year ago, or 18 months ago, they were saying, well, let's do a proof of concept. Now clients are saying, well, we have this big opportunity. We need to move to Hadoop and big data techniques right now. So usually they'll start with, say, ETL and speed up the ETL processing. And then they'll move into big data warehousing, and then perhaps real-time analytics, and then start making data-driven decisions along the way. And then you want to move those data-driven decisions as close to your customer activities as possible, which drives you to real-time as well. So there is a progression, and it follows something like the path I just spoke about.
Thank you, Douglas. I believe this concludes our webinar. Thank you, Drew and Douglas, for enlightening us on the essential steps of identifying your business goal and then building the right infrastructure to support it. Look out for the recording early next week. Have a great rest of the week, and thank you, everyone, for joining.
Thank you all.
Thank you, everyone.